Hey YouTube, I was recently watching some videos about neodymium magnets, creating supposed free energy. Excuse the noise in the background, that's the dog. Either way, they said pull some hard drive magnets out. I've got old hard drives laying around, so you can see I pulled a few of them out. And the first thing I want to say is be very careful with these magnets. You can see this one is broken. The reason it's broken is pretty simple. I got them too close together and it snapped together and almost took out my finger. So you need to be really careful with these things. They're very, very powerful. Either way around, one of the first experiments that they had on there just showed a basic small coil. This coil that I built here, this little cheap copper wire coil, nothing fancy, nothing space, etc. Either way around, one of these experiments showed one of these coils being placed just a magnet like this, tied to a couple of motors, and the motors suddenly take off running, like from free energy or something. Physics says this isn't possible. It's simple electronics says it isn't possible. That, hey, I've got time sitting around, so I decided to try it. And that's what we're going to do right now. I'm going to pause the video. I'll have to restart the video because I need to get everything set up here. And we're going to show you that, of course, this is total, smoke and mirrors. It's BS. I can't tell you exactly how they're doing it. What I can tell you is it simply doesn't work, and that's the whole point of this thing. So I guess, actually, let me just keep the video running. This is an El Cheapo voltmeter. I've got a nice fluke around here, but I don't know where it is right now. It doesn't matter. We can see it's set on AC right now, and the AC, basically, it's very, very low setting, 2 volts AC. And so we're picking up 0.012 volts just from RF interference in the air. Anybody who knows anything about electronics can tell you that kind of stuff, but that's completely and totally normal for the leads just hanging there. We're going to bring one lead around and see if we can connect it here. I'm going to set the camera down a second, so hang on. We'll try to set it down. Alright. Now we have one lead connected, and it's just hanging in midair. It's setting, oh well, we'll just set it right on top of the magnet. How's that? And just this lead connected alone has brought us up to 1.8 volts. And this is probably not going to matter. I'm going to move it around here and we're going to find out. We're just hanging in space here. Excuse the computer in the background. And it actually has dropped down a little to 0.02. This is the magnet, and we're just basically spinning the coil above it. No lead, only one lead connected. And if you can see the meter there, fortunately you can't. It's hard to move these magnets around because I don't want them to snap and get my finger again. We're just swinging this above it, and this is the theory of an electronic, what's called the EMF. Magnets cutting the lines of force on the wire coil will produce energy. That's been known for a really long time. That's how motors work. So swinging this over it, and congratulations, we're not creating much of anything, even open air. You gotta remember this is open air. This is not under load. So the next step in this thing would be to connect both leads to it. And what we should see here from this experiment that I saw on YouTube, of course, that we're disproving at this point, because that's the rules of science. If you do an experiment, hey, that's fine, we'll all agree with it, as long as we can reproduce it. And that's the kind of the point of this, is me trying to reproduce this. Let's see, we're back up, just setting there to 0.1 volts. Now we're actually going to put a load on it. We're actually going to complete the circuit, if you will. And by completing the circuit, what we should see is the voltage go way up. And of course, we see nothing. Absolutely dead. And the reason this is absolutely dead is very simple. It's explained in physics. It's explained in electronics. It's a well-known theory that unless these magnets are moving around this electronic wire, this piece of copper wire, or unless the copper wire is moving past the magnets, in other words, unless we have something moving here, you're going to get no voltage. We have no voltage here. We're not going to have any voltage here. It's just plain straightforward physics. So the little experiment is these two, or this coil, it's got one of these kind of magnets placed very, very close to it, actually further away than I have this magnet. It's tied to two electric motors and a couple of little lights, and it's supposedly running away, this free spin. He stops the motor and then lets it go, and the motor takes off again. What I suspect is that underneath the table is a small electromagnet. An electromagnet is an AC magnet. It's a force created by passing AC over coils of loops of wire. It'll produce a pretty strong and pulsing magnetic field. And I really think that that's what's happening, is having this, this magnet setting, underneath a table like this, and it's pulsing away at this coil, is actually what's producing the voltage in the thing. And of course, that's what's actually making it work. It looks like this thing's already 6 minutes long. I'm going to post a second video on the second experiment. That's why I have 4 magnets out here required for the second experiment that I saw in here. And once we figure out that that's smoke and mirrors as well, I'll hopefully leave you alone, and you can go on and say, oh, look, at least someone took the time to bust these people. So thanks for watching. I'm going to leave comments turned on but approved only, because these guys that do this kind of crap are just really kind of trolls. So any good comments I'll approve, and anybody who wants to refute me and say I did this wrong or did that wrong, I mean, that's fine. I mean, I have no problem changing the experiment to try to see if you guys are really telling the truth. I don't think it's true, but I'll give you the chance. But thanks for watching again, and take care.